Hello to all my viewers. This is Dr. Dhaval Maheta, and today we will understand how to plot the lift chart in probabilistic neural network in KNIME. A probabilistic neural network is a type of artificial neural network that is used for classification and pattern recognition tasks. PNNs are based on the Bayes theorems of probability and they work by estimating the probability distribution of the input data. PNN consists of four layers: an input layer, a pattern layer, a summation layer, and the output layer. The input layer receives the data and the pattern layer converts it into the probability density function by calculating the distance between the input data and the prototypes in the pattern layer. The summation layer combines the PDFs and it calculates the posterior probabilities which are then passed to the output layer for the classification. PNNs have several advantages over other types of neural networks, such as their ability to handle non-linearly separable data, their fast training time, and their ability to classify the data with high accuracy. However, they are not as widely used as other types of neural network because they can be computationally expensive and they require a large amount of memory to store the prototypes. After running the PNN algorithm, it is necessary that we check the classification accuracy. This we will do with the help of confusion matrix. Kindly refer my previous video to understand the interpretation of the confusion matrix. In this video, I am going to talk about the lift chart. A lift chart, also known as a gain chart, is a visualization tool used to evaluate the performance of the binary classification model, such as decision tree, logistic regression, naive Bayes, support vector machine. The chart compares the predicted probability of the positive class against the actual proportion of the positive instances in the dataset. Lift measures how our model is performing in prediction against the prediction without the model. You can see here that the data will be divided into 10 parts, each part having the probability of 10%. So in first part, out of 1000 cases, 876 events happen. In second part, 743 events happen. Now, what is the interpretation? So, in the first part, out of 1000 observations, the number of events that occur are 876, which is 22.70%. 876 divided by 3859. The gain for the first part is 22.7% divided by 10 because the probabilities have been divided into 10 parts. In the second part, out of 1000 observations, 743 events occur, which is 19.25. So the gain for the second part is 22.7 plus 19.25, 41.95. The lift is 41.95 divided by 20. How? Let's try to understand. 10% for the first part and 20, second 10% for the second part, and therefore 10, 20. 41.95 divided by 20. So the lift is 2.098. And for the first one, it is 2.270. So if the lift is more than 1, it means that the model is working better than just the random guess. Now, how we can generate this in KNIME? Let's see. So first of all, I will activate the input output node from here. I'll browse the dataset. I'll connect heart1, right click on it and execute. Now I will activate the column filter to only select those variables which I require in my model. Right click on it, configure. I'll take all the variables on left hand side. I will only include age, resting blood pressure, cholesterol, maximum hours of exercise, heart disease. Click OK. Right click on it and execute. Now again right click on it and you can see the filter table. Now let's try to normalize this as all the variables are on different scales. So I will activate the normalizer. Right click on it and configure. Click OK. Right click on it and execute. Again right click on it and see the normalized table. So you can see that now all the variables are in the range of 0 to 1. I'll activate the partitioning from here so that I can split the data into training and testing data set. Right click on it, configure. 80% for training and 20% for testing. Stratification to be done according to the heart disease. Right click on it, execute. Now I will activate the PNN learner. Make sure the target column is a heart disease. Right click on it and execute. I'll activate the PNN predictor. Now I'll connect the partitioning with the PNN predictor. So this predictor will get its learning from this node and it will get the remaining 20% data, the testing data from this partitioning node. Execute. Again, right click on it and you can see the predicted data. So this is the predicted data according to the algorithm and this is the original data. So in my previous video, we have discussed how to interpret the confusion matrix. So you will have to activate the scorer, which generates the confusion matrix. Right click on it, configure, make heart disease here, click OK, right click on it and execute. Again, right click on it and you can see the confusion matrix. So 45 plus 82 cases have been correctly classified. In this video, we are going to talk about the lift chart. So activate the lift chart from here. Disconnect this line. Now connect the predictor with the lift chart. Right click on it, configure, heart disease, so keep heart disease on, probability column heart disease, positive label it's yes, click OK and right click on it and execute. After executing, click on image. So you can see the lift chart. So for the first 10% case, the lift is 1.7, which is quite good. The red color is a lift line. For next 20% cases, it is 1 point something like 3. The lift decreases after 65 or 60 percentage of the observation. You can also generate the cumulative gain charts. Go in configure, general plot options, so cumulative gain, click OK, right click on it and execute. Again, right click on it and see the image. So this is a cumulative gain. So this is a way you can generate the lift chart in KNIME. For more videos on KNIME, you can subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos on KNIME.